Hi, this is Julie Harland. Please visit my website at yourmathcal.com where I organize my videos by topic. A fraction that contains one or more fractions in either its numerator or denominator or both is called a complex fraction. So below are 5 examples. The first example, we have 3/4 over 5/8, so it has a fraction in the numerator and a fraction in the denominator. The second one, there's an x alone in the numerator, but in the denominator, there's two terms, 2 minus x over 3, so there's a fraction there. And you can see from the third, fourth, and fifth examples, I have fractions in both the numerator and denominator. Complex fractions are not in simplified form. That means we can simplify further so they don't look complex. And there are two commonly employed methods we could use. And these are a quick overview of the two methods. The first method is to write both the numerator and denominator as single terms or fractions. And then you'll multiply the numerator by the reciprocal of the denominator. The only one in the examples above where you already have the numerator and denominator written as a single term or fraction is the very first one. We have just a single fraction in the numerator, 3/4, and a single fraction in the denominator, 5/8. All of the rest of them are not in that form. If you look at the fourth example, 1 over x minus 2 over x squared in the numerator, there are two fractions in that numerator separated by a subtraction sign, so that's not a single fraction. And in method 2, you don't need to have it in the form as the very first example up here. Instead, to simplify the complex fraction, the first step would be to multiply the numerator and denominator by the least common multiple of all the denominators of all the fractions in the numerator and the denominator. All right, we're going to simplify this complex fraction using each method. Right, so the first method, we have a simple fraction in the numerator and a simple fraction in the denominator, so we can say that's the same thing as the numerator, 6x cubed over m to the 5th divided by 3x to the 10th over 5m to the 7th. And since we're dividing by a fraction, that's the same thing as multiplying by the reciprocal. So we have 6x cubed over m to the 5th times 5m to the 7th over 3x to the 10th. And now we have to simplify this using our laws of exponents, etc. So one thing I notice I could do is that I can cancel the 3 into the 6, so that'll be a 2. And notice I have an x cubed in the numerator and an x to the 10th in the denominator, so I have more factors of x in the denominator. So if I cancel that, basically you subtract the exponents, right? 10 minus 3, and that will give me an x to the 7th down here, so times. And we also can deal with the m to the 7th over m to the 5th. There's more m's in the numerator, so I'm going to subtract 7 minus 5, so give me a 1 here, and 7 minus 5 will give me that exponent of 2. So we have to be very careful. What's left in the numerator, I have a 2 times 1 times a 5 times an m squared. So actually I've got 2 times 5 is 10 m squared. And in the denominator I have 1 times x to the 7th. And now we have it simplified. Now using the second method, don't worry about whether there's just a single fraction or not in the numerator, but I look at the denominators. So in the top fraction, the denominator is m to the 5th, and in the bottom fraction, the denominator is 5m to the 7th, so the least common denominator is actually 5m to the 7th. 5m to the 7th, so I have to multiply the numerator by 5m to the 7th and the denominator by 5m to the 7th. Basically, that's like multiplying by 1. So we have 5m to the 7th over 1 times. Notice I'm writing it as a fraction just so you realize it's in the numerator, but you don't have to put over 1. 6x cubed over m to the 5th. And then in the denominator, I have also a 5m to the 7th over 1 times 3x to the 10th over 5m to the 7th. Not everybody has to write that step, but I like to show it. So these completely cancel, right? So I can see what's going to happen in my denominator. All I'm going to have is a 3x to the 10th over 1. So see how I've eliminated the fraction in the denominator? And in the numerator here, I have an m to the 7th over m to the 5th. So I have more m factors in the numerator up here. So I could do 7 minus 5. That'll give me an m squared. So I've got 5 times 6 times m squared times x cubed. So that's 30 m squared x cubed. All right, not quite done. My nail could cancel. 30 over 3 is just going to give me a 10. And I have more x's in the denominator, so I subtract 10 minus 3. This will give me an x to the 7th in the denominator. So my final answer here, I've got 10 times m squared. And in the denominator, I have x to the 7th. Same answer, 2 different methods. It's usually easier to do the top method if you just have a simple fraction in the numerator and a simple fraction in the denominator already.